All right, so we're going deep today into stats models.
Stats models.
Yeah, stats models. Have you ever heard of it?
Oh, yeah.
I feel like that's one that I see thrown around on Twitter and stuff, but I don't actually know what it is.
Yeah.
So we're doing a deep dive on stats models today.
Cool.
I have a ton of notes here, and I'm really excited to kind of pick your brain about it.
Awesome. Yeah, this will be fun.
So maybe just to start off, can you give us a really, really basic overview of what stats models is?
Sure. Yeah. So Statsmodels is a Python library that's used for doing statistical modeling and analysis. And so it basically gives data scientists and statisticians a whole bunch of tools and functions to be able to build statistical models, analyze data,
Right.
and really just kind of get insights from data.
Okay, cool. And so when you say statistical modeling, what does that actually mean?
So statistical modeling is basically trying to find relationships between different variables. And so you might have a set of data and you want to see, is there a relationship between, say, the amount of rainfall and crop yield or the amount of hours studied in exam scores or something like that. And so these statistical models help you to actually quantify those relationships and figure out, is there a strong relationship? Is it a weak relationship? And what does that relationship actually look like?
Gotcha. Okay, so it's not just about eyeballing it and being like, oh yeah, it looks like there's a correlation there. It's about actually using math to figure that out.
Exactly. Yeah. Yeah, it takes the guesswork out of it.
Okay, cool. And I think I've heard you use the term regression analysis before. Is that part of stats models, or how does that fit in?
Yeah, definitely. So regression analysis is one of the core functions that you'll find in stats models. And so regression analysis is basically a way to find that line of best fit. So if you could picture a scatter plot of data points, regression analysis is the method that's going to actually draw that line through the data and tell you what that relationship looks like.
Okay, so this is all starting to make more sense now. So it sounds like stats models has a lot of different tools and functions like you were talking about.
Right.
So besides regression analysis, what are some other things that people would use stats models for?
Yeah, so another big area is hypothesis testing. And so this is something that's used a lot in research and science. And so hypothesis testing basically lets you test out those hunches that you have. So let's say you think that there might be a difference in test scores between two groups of students or something like that. You can actually use stats models to test that hypothesis and figure out if that difference is statistically significant or if it's just due to random chance.
Yeah. Oh, interesting. So it's like taking those science fair experiments that we all did in school and actually applying it to real data.
Exactly. Yeah, give you that framework to actually rigorously test out your ideas.
Okay, cool. And I know you can also use stats models for making predictions about the future, right? Is that a thing?
Yeah, definitely. So time series forecasting is another big area within stats models. And so this is where you're using data over time to basically make predictions about what might happen in the future. So you could think about things like stock market trends or weather forecasting or even, website traffic. All of those things have a time component to them. And stats models gives you the tools to be able to actually model that data and try to predict what might happen next.
So it's not quite a crystal ball, but it gives you some insight into what the future might hold.
Exactly. Yeah, it gives you that ability to kind of look ahead based on past data.
Okay, cool. And one last question before we dive into some more specifics. You mentioned that stats models is a Python library. So does that mean you need to be a coding whiz to use it?
Not necessarily so. While having some coding knowledge is definitely helpful, there are a lot of resources and tools available that make it pretty user-friendly, even for beginners.
Okay, that's a relief to hear because I'm always a little intimidated by anything that involves coding.
Yeah, get it.
But I am getting more and more curious about how stats models actually works. What are some of the nitty-gritty details of the different features and models?
Okay, yeah, we can definitely dive into that. So you know how we were talking about regression analysis before?
Yeah.
Well, one of the things that our source material mentions is that when you're using stats models for linear regression, it actually needs this thing called a constant column.
A constant column? What's that?
So it's kind of like adding a y-intercept to your equation.
Yeah.
If you think about it like drawing a line on a graph.
Okay.
If you force that line to go through the origin, you might miss the real relationship between the variables. So that constant column, it gives the line more flexibility to fit the data accurately.
Oh, I see. It's like giving it that extra degree of freedom to move up or down.
Exactly.
Okay, that makes sense. And speaking of things that might seem a bit technical at first, let's go back to hypothesis testing for a second.
Okay.
You mentioned the p-value.
Yeah.
And how it's super important for understanding whether your results are actually statistically significant.
Right.
But how do we actually interpret that p-value in real life?
Yeah. So think of it this way. Imagine you're testing a new drug to see if it actually works, if it's effective at treating a certain disease.
Okay.
So you do a clinical trial, and you find that the group that's getting the drug shows improvement compared to the group that's getting like a placebo, a sugar pill.
Right.
But how do you know if that improvement is because of the drug or if it could have just happened by chance?
That's a good point. Yeah.
That's where the p-value comes in.
Okay.
It tells you the probability of getting the results you observed if there was actually no real difference between the groups.
So it's like saying, how likely is it that we would have seen this improvement even if the drug didn't actually do anything?
Exactly.
Yeah.
And in most scientific research, a p-value of 0.05 or less is considered statistically significant.
Okay.
So that means there's only a 5% chance of getting the results you got if there was no real effect.
So it's like a pretty high bar to clear.
Right. It means you can be pretty confident that your findings are actually legit and not just a fluke.
So what happens if the p-value is higher than 0.05?
Well, then it means that your results could have more easily happened by chance. It doesn't necessarily mean there's no effect at all, but it does cast some doubt on how strong your evidence is.
So it's like a warning sign to maybe do some more investigation.
Exactly.
This is where it gets really interesting, right? Because it's not just about crunching the numbers, but also about understanding what those numbers actually mean in the context of your research.
That's right. It's all about interpretation and critical thinking.
I love that. Okay, so we've talked about regression analysis, hypothesis testing, and p-values. And all of this is starting to paint a clearer picture of just how powerful stats models can be.
Right, and how versatile it is, too.
Yeah. And speaking of versatile, you mentioned earlier that stats models can also be used for time series forecasting.
Oh, yeah.
And we briefly touched on the ARIMA model, which I have to admit sounds a little intimidating.
It's a mouthful for sure.
But it seems like it has a lot of potential. So could you maybe unpack that a little bit more? Like, what does ARIMA actually stand for, and how does it work in practice?
Sure. So ARIMA stands for Autoregressive Integrated Moving Average.
Okay.
And it's basically a model that uses past values of the data to make predictions about future values. So, for example, if you were looking at stock prices, you could use an ARIMA model to try and predict what the price might be tomorrow based on what it's been doing in the past.
Gotcha. So it's like looking for patterns in the historical data.
Right. And the cool thing about ARIMA is that it can account for things like trends and seasonality in the data. So if, the stock prices tend to go up in a certain month every year, the model can actually factor that into its predictions.
So it's not just blindly looking at the past, it's actually taking into account those recurring patterns.
Yeah.
That's really cool. Okay. I'm starting to get a better grasp on this whole ARIMA thing, but how do you actually choose the right ARIMA model for your data? Like, I imagine there must be tons of different variations.
Yeah, there are, and it can get a little technical, but essentially it involves analyzing the data to see what kind of patterns are present and then choosing the model that best fits those patterns.
So it's a bit of an art as well as a science.
Definitely. It takes some experience and judgment to really get it right.
This is all so fascinating. I'm realizing that statistical modeling is way more prevalent in our world than I ever realized.
Oh, yeah, it's everywhere.
It's like a secret language that's being used to make decisions in all sorts of fields.
It really is.
Yeah.
And the more you understand that language, the more empowered you become as a consumer of information.
That's so true. Okay, so we've talked about how stats models can be used for things like regression analysis, hypothesis testing, and time series forecasting. But let's get even more specific. Like, what are some real-world examples of how this stuff is actually being applied?
Sure. So in healthcare, for instance, stats models is being used to analyze the effectiveness of different treatments and identify risk factors for diseases. Researchers can use it to study the impact of lifestyle choices on health outcomes or to evaluate the success of public health interventions. It's really powerful stuff.
Wow, that's amazing. It's like using data to actually improve people's lives.
Yeah. And in the business world, stats models is being used to analyze customer data and identify patterns in buying behavior. So companies can use this information to develop more targeted marketing campaigns, personalize product recommendations, or even predict future sales trends.
So it's not just about understanding the past, it's about using that understanding to shape the future.
Exactly. And in finance, stats models is used to model investment portfolios, assess risk, and develop trading strategies. It can even be used to forecast economic indicators like inflation or GDP growth.
My mind is officially blown. It seems like there's no end to the applications of statistical modeling.
The possibilities are truly endless.
It's like this hidden world that I've been completely oblivious to.
It's a whole new way of seeing the world.
And you know what? It actually sounds kind of fun. Like there's a certain appeal to solving these statistical puzzles and uncovering hidden trends.
Yeah, it can be very rewarding.
It's like being a detective, but with numbers instead of clues.
Exactly. You're using data to solve mysteries.
Yeah, I love that analogy. Okay, so we've covered a lot of ground today. We've talked about the different functions of stats models, we've looked at real-world applications, and we've even touched on the bigger picture of what it means to think statistically.
And a great discussion.
But I know that for some people, statistical modeling can seem intimidating, especially if you're not a math whiz. So what advice would you give to someone who is interested in learning more about stats models but feels a little overwhelmed by it all?
Well, first of all, I would say don't be afraid to start small. You don't have to become a statistics expert overnight. Just focus on the basics and build from there.
Yeah, take it one step at a time.
Exactly. And there are so many resources available online now, like tutorials, documentation, online courses. You can really learn at your own pace.
And don't forget about the power of community.
Right. There are tons of online forums and communities where you can connect with other people who are learning and get help with any questions you have.
I think that's one of the best things about the data science world. It's so collaborative and supportive.
Definitely. Everyone's in it together.
And even if you don't become a stats models expert overnight, just having a basic understanding of these concepts can be incredibly valuable.
Absolutely. It can help you to have more informed conversations about data, to understand research findings better, and even to spot potential biases or misleading statistics.
So it's not just about becoming a master statistician, it's about equipping yourself with the tools to think critically about the information that's constantly bombarding us.
It's about becoming a more informed and discerning consumer of data.
I love that. So as we wrap up this deep dive into the world of stats models, I want to leave you with one final thought-provoking question. Now that you've had a glimpse into the power of statistical modeling, what real-world problem could you apply it to? What data in your own life could you analyze? What assumptions could you challenge using statistical modeling? The possibilities are truly endless.
Yes, I was like you were saying before about the p-value. Like, it's not just about the numbers themselves, it's about what they mean in a larger context.
Exactly. It's about the story behind the numbers and being able to interpret that story accurately.
So it's not just about becoming a master statistician, it's about equipping yourself with the tools to think critically and make sense of the information that's constantly bombarding us.
It's about becoming a more informed and discerning consumer of data. I love it. So as we wrap up this deep dive into the world of stats models, I want to leave you with one final thought-provoking question. Now that you've had a glimpse into the power of statistical modeling, what real-world problem could you apply it to? What data in your own life could you analyze? What assumptions could you challenge using statistical modeling? The possibilities are truly endless.
Yeah, I mean, think about all the data that we encounter every day, from our personal finances to our health and fitness to even just like our social media habits. There's so much potential there to uncover insights and make better decisions.
It's like having a whole new set of lenses to view the world through.
Exactly. And the best part is that with tools like stats models, it's becoming easier and easier for anyone to access and analyze this data.
So there you have it, folks. Stats models, a powerful tool for understanding and interpreting the world around us.
It's a gateway to a whole new level of insight and understanding.
I don't know about you, but I'm feeling inspired to go out and find some data to play with.
Me too. It's amazing what you can discover when you start digging into the numbers.
Thanks for joining us on this deep dive into the world of stats models.
It's been a pleasure.
We'll see you next time for another data-driven adventure.